mapped this out. The bearing down here and bearing diameter up here are the two most critical diameters. Right now we are on size for this one, and this one down here we're actually 2.5 thousandths oversized. And this side in the middle here, it actually takes a rise there, and we're about 4 thousandths heavy here. So what we're going to do is we're going to go ahead and we're going to come in here, and we're up to size right around where that mark is right there. And we're going to come here, we're going to go ahead and touch into that mark, and we're going to go ahead and increase another thou. We're going to take this cut across here, and we come in fine here. If this doesn't straighten out, which I doubt it will, then we're going to go ahead and come in here, and we're going to slightly undercut the center section here after we get this side over here. Taking 1/1000th there. Barely feel it. Okay, we're good on our diameter all the way down. Now we want to go ahead and, I mean, barely see that, but we want to go ahead and we want to blend that in, and then we want to finalize our shoulder thickness here. And I think we're pretty close on this one here. This is like 340 on that thickness. And so let's go ahead and let's give that a blend in. See if we can live with that thickness there. And I'm not real fussy. This is like 330, and we were just trying to go between 5/16 or so. And we'll go ahead and we'll slip the thing out of the chuck a little bit, and then we're going to kiss that with a 45. But we're going to go ahead and polish the shaft before we actually slip it out here. We fudged it a little bit to come in here, but we were able to get this diameter smooth without really having any lips, you know, I mean like thousandths here or there. We have a little different discoloration in a couple spots there, but once we polish this, it will completely disappear, and then we'll be able to come in here and kind of give that a little rub in there. nice clean finish. We're going to go ahead and slip this out just a little bit, and we're going to kiss a 45 on there. Actually, I think I'm going to go ahead and we're going to set up a tool real quick. That way we'll have it for the next one as well. Okay, we found a pointed tool bit. I think originally it was probably a threaded insert, and then somebody's modified it a little steeper angle, and I kind of like it, and I'm going to use that to come in and break that edge there. So we're just kind of setting this up in a holder of its own, so it'll be ready for our next shaft as well when we get it in here, and something like that. Alright, here again, we know that this is way high, and we'll go ahead and we'll set this up. Okay, we're still high. Okay, we're doing good there. Lock that down. I always like to spin this by hand and make sure that we're clearing before we get started in here. I think a good 1/16 of an inch, at least 50 thousandths chamfer right there would be great. Alright, let's get this out and we'll get the next one in. Alright, we're set up on the K&T for the last machining operation, and what we have is a scallop cutout. So there's a clamping collar that comes across here for the tiller probably, and I think it's 12 millimeters a slot. This is a piece of 7/16, but it's going to be adequate to go ahead and give us our alignment and everything else. And then we have a pair of cutters that will be able to come in here in the spindle to cut that radius. Now first we just want to go ahead and lay out where our scalloped area is going to be, and we're going to measure from the shoulder at the base of the top of the rudder blade itself up to here, and it looks like 24 9/16 and 25 1/16. So we're going to go ahead and give some color there. Let that dry for a second. And we're also going to look at what it is. It's 1/2 inch and a 1/2 inch down from that edge right there as well. We'll verify that. Now it measures 1/2 inch, but actually this is a 1/2 inch shank, and it won't quite fit in there. So it leads me to believe that, I mean, everything else is metric on these things, so it leads me to believe that it's 12 millimeter, and 24 1/16 and 25 1/16 actually match up right on the money there. Alright, now we want to set this scallop in line on that one as it is on this one here, and then we can set the rudder post when we're building the blade, aligning that which the square lines up with the blade. So we're going to take and we're going to clamp this down, level this out, and we're going to put this shaft in the same position as this one in rotation so that this alignment will be matching for this rudder. And then we're going to do the same thing with the other rudder, which still has a blade on it, but we'll be able to get it up here and we'll clamp it down the same way. Now I like to just go ahead and use my toe clamps, get my long ones, and we can place 2 of these right on here. So it's holding that shaft parallel in that groove, and this one here, and this groove here. A little bit of tension on here, eyeballing these. Alright. Now, main importance is we want to make sure that this level here is the level in line with the spindle, meaning this is what we're cutting, so we need to make this 100% level. So by taking our crescent wrench here, we can go ahead and bump this until we get the bubble level with the rod resting in the bottom. Now we go over here, and that also looks level. I just want to make sure that we're getting this. That's level. That's level. So we can go ahead and we can crank this. I thought that it was slightly off, but we'll double check that in a minute. Okay, we're level there. We're level there. And this is reading level. Must have been the way I was looking at it. Alright, we've proven that this is level with this, and this is level now with the table, and everything's set. Alright, we got this tension down, and our scallop cutout is level with this. This is level with the table. Now we can go ahead and machine the scallop cutout in that shaft there. Alright, we're going to go ahead and change out our cutter. We got to get our 1/2 inch arbor, get that one pulled out, and we're going to change it and start getting this machine up in position to cut that. With our scale, the butt end of our scale, I kind of hold it up against the flute of the end mill here, and I can see its alignment to my lines here, and I'm a little bit shy of each side because this is a 7/16 cutter here, so we're gonna take and come down. I think we should be in here far enough there. This length is about 1 3/8 of an inch. Just a little bit out past this length right here. The more we come in, the stronger the cut will be, because the center point of leverage will be closer in on the cutter itself. So I'm kind of eyeballing down there to see that. Kind of like about right there. We'll lock the table in there. Alright, I think we're pretty close. Now we're just going to establish a depth of this cut. And we're just taking the butt end of our dial calipers here. And we got about 238. Call it 238, 240. It's clearance for a pinch bolt. We do want it real close. We can see that the threads of the bolt rubbed the bore, so they had it pretty tight. All right, let's give it some RPM here. Try it slow on the slower side there. About 119 on the RPMs. This is Aquament material. We are going to run flood coolant on it. We are going to touch off first, so I can set 0 on my dial. light coming in the window really plays a good tool on touching off on this mill here. I know it's not too good on camera angles. Sometimes I'm limited only to a couple shots due to the backlighting. Okay, we touched right there. Alright. Okay, we're only 6 thousandths off the zero without moving the dial. Alright. We got zero. We're going to kind of clear off our stuff here. We're going to have a little bit of coolant coming down. Okay, now we're just going to start feeding it by hand. Okay, that's 90 thousandths there. I'm just giving it a little bit more coolant and I'm kind of moving it over to the center of the cutter here. There we go. I just don't want it to be shy of any lubricant there. $125, $135, $150, $175, $8. Okay, there's 200. $225, and $230, I'm going to call that $235 right there. And we're going to put a mark because we're going to be moving side to side and coming down plus a little bit. We want to double check our depth to that cut. Alright, we let it run just a little bit so it's got any tool pressure, it'll cut it. Alright, now I'm just coming back out of it. Okay, we just set our in and out dial at 0 so that we can unlock this and we can bring it out past here just so that we can check that depth with our dials calipers again. $230. All right, we got another 8 to 10 that we can go on the depth. All right, we take a look at side to side. way will give us our width that we want. So first off, we're going to bring it back 20, go down, move back the other way so that we're conventional climb. Down on that side, across and up. It's only 20 down, an extra 10 to the depth, over 20 and out. Okay, I don't have a readout or anything else on this machine. So what I have the table locked right now where we went down, we plunged, we came straight up. So I take the backlash, and there's 20, 40, 50 thousandths backlash in this machine. So I went ahead and I marked the backlash. I'm giving or take a couple thousandths, you know, so I'm a little bit over there, but okay. Then I put another line for 20 thousandths past each one of the full strokes here, so that I can go ahead and bring it over here, so I don't have to come back and set it at any zero. In fact, it's better not to try to put a zero in your equation for this operation. Just take your backlash, put 2 marks, go past your mark the amount that you want to go back and forth on your cut, and then leave it at that. So we're going to adjust it to the first one. So we're going to come over here, which is 20 more than we were in that one direction, and you confirm it by going back there. It should be about 20 to get to here. So we're going to take the cut, go all the way down, then we're going to go across the bottom by moving this handle over to the other line and then up, and that will take our 40 thousandths that we want to take out of their total. Okay, it's starting to hit there. The reason why it's taking so long is because the radius is pretty close to the depth as well, and we're not really taking a whole bunch. Okay, right there we're down to the same exact depth that we were, and we're going to go ahead and we're going to take another 10 just to make sure that we have enough clearance for that bolt that's being used. Alright, now we're going to go ahead and go across the bottom. Five more. I'm just inching it a couple thousandths at a time here. Alright, we're going to let it spring cut right there. Alright, now we're going to feed down. Come out again so we can double check our width and our depth. And it kind of depends on where you're measuring, but I got somewhere around 480 in this area is the planned width here. 475, 480. What about the depth? I got 244, 245. All right, we're within 3 thousandths on the width, and we're over. I think we got like 4. I do have a burr right here, so I'm going to take that off and reconfirm that. I don't think there's, let me take a file, let's nicer. 241. I'm happy with that. We can massage this a little bit with some the Scotch-Brite pad, 3M Scotch-Brite pad, a little 2-incher. We'll massage that surface right around the outside edge. And I'd rather have this scallop a little tight because I think it also does the location on the steering arms. All right, let's go on to the next. All right, we got this set out here. We're going to go ahead and straighten it. Not that we know we're going to have some welding going on here. We're going to have some pull, but to do all the final setups and everything else, we like to have it 100% running true. And if we keep uniform and we stagger around, we'll keep it running true. Right now we have 50 thousandths run out here, and we progressed it back. It's equal all the way back into here. So it kind of stems where we grabbed a hold of this and turned this, and we grabbed a hold of this and turned that. So we got a little bit of difference right in the middle here. So we're going to leave this. This is running 100% true, and we're going to go ahead and do our heat straightening and bring that down. And we'll do both of these, and then we'll get inside and we'll start playing around with our webs that are going to support the foil shape. Okay, just a couple tiny spots here that we worked on, and we're able to get that about a thou and a half on the end. Alright, now we're going to do the other one. I just put this other one up here and put the indicator on here. And it's only running out, and so we don't have too much to play with here. Let's see, there's 10 there. There's about 8 there. Probably the same thing, just kind of telescopes out. About 6 or 7 there. About 3 there. You know, so it progresses back to here. So, all right, we're gonna go ahead and we're gonna take that 10 out there now. After one adjustment spot there, we're within one and a half thousandths. All right, we're done. We can go inside now where it's a little warmer. All right, we just tightened this up in the chuck, 3-jaw, just hanging out freehand, and you can see how nice it runs now. All right, now we're just gonna polish out our blue spots there from heat straightening. All right. So you can see the spots. They're just color spots where I actually had to contact it with some heat. All right. To the naked eye, I can see just a little bit right in there, but for the most part, they're pretty well gone. And that was the only spot we actually had to work. All right, we're going to go ahead and pull this one out and put the other one in and head to the other room. All right, we're getting ready to cut out our fish webs that will be the foil shape to our rudder. And they slip over the rudder stem this way. These are lightning holes here, so they're not real critical, but they are a good source of practice for small intricate cutting. After this outside starts and everything else, this little notch on the end should be fairly simple, but I want it to be pretty accurate for holding the horizontal supports front and back of the rudder there for the shell of the rudder to come down and have a continuous welded seam on. That's how we're going to get the actual foil shapes front and back to be 100% what the customer wants. Now, cutting out stainless steel on a PlasmaCAM is probably one of the more difficult materials that I found cutting on there. And whether you're cutting 1/8 inch, 3/8, or 1/2 inch thick materials, you really would like to have the same outcome and the same quality, shape, and all of that in your project. And I kind of picked my own logo combination of letters there that I created just as test patterns, and I do it quite often. If I'm rusty or unsure of what speed and combination of amperage and everything else to play with. Now, I've already made 6 holes over here at different settings, and I'm getting ready to make one more hole to make a pick of how I want to start cutting out my fish webs. And of course, I always go to the recommended or suggested settings. And what I found, and this is for most everything, okay? And I don't believe it's just to the unit that I'm at. I believe that cut speeds, quality, and all of this is all talked about like a bunch of used car salesmen. And sure, you can get your plasma cutter to cut at that speed and everything else, but when it comes right down to that edge and the quality of cut you want on that edge, you've got to tune that into your own machine. And for every instance that I've seen where I get better performance on that edge is deviating from the suggested or the bragged about speed. Alright, so we're going to make one more cut here, and we're going to go by the settings here, and I'm actually working 3/16 on the thickness there, or the closest thing would be 7 gauge, and the stainless steel 7 gauge recommends 110 inches per minute. And if you look in the book here, which I don't actually have 7 gauge in here, and this is the recommended for my SL60 torch, and I got 1/8 and 1/4 on the thickness, and it gives me 175 for the 1/8 and 80 for the 1/4. So the 110 on my other sheet that I got for this off the line internet, it falls right between those numbers. So we're going to go ahead and use that as the recommended speed, inches per minute, that it should be cutting at. And then I'm going to bring you in and we're going to take a close look, because in the other 6 holes, we're cutting the 7th hole now. The other 6 holes, I deviated speed and also height to get where the combinations that I have in there now. We'll bring you in close and we'll take a look at those before we get into cutting out my actual parts here. So I'm kind of giving you just a little feedback of walking the talk and what the truth is about the quality of the cut. All right. So let me get you moved in. Okay, this hole we're gonna put in is gonna be right around in here, because I'm putting it down on the other side. The fish that we cut out, that's why I kind of picked this, is void areas. So I did this at 60, 50, 40, 30, 25, and 25 here, but I changed the depth from 150 to 190, and I ran these all on 125. This is going to be 190 at 110 inches per minute, and that's what this hole is going to be right here. Here we go. Okay, this torch cut it out, but it didn't even cut it out well enough to let that slug fall out. Almost like melted it right back into it. Okay, so what I'm going to do, this is the hole we picked, but I'm going to show you the reason why we picked this hole. Alright, and okay, this is my depth gauge. Okay, now the first hole, 125 torch height at 60 inches a minute. Whew, that's warm. Okay, this is 50 inches a minute, and the reason why I'm doing it this way here is because the true side cutting, they're all 3/4 inch holes. drawn out and then plotted out and cut. That's 40. Here's 30. Now I'm touching the little web right there. I could probably sneak down just a little bit. Now we're getting pretty close. Here's 25 thousandths. I'm almost right down to it. Okay. Now cutting at 25 and 190 on the height, I'm able to get almost a true 3/4 inch hole. And I also was able to take my calipers, and I got 742. Like I said, these aren't critical holes, but 728. I was 728, 729. It was, and I measured all these holes were just copied and put. So the start and pierce position are the same in all of them. They're all on this side here. So I'm measuring all of them in the same direction right here. Like you get down here, and we're at 688. There's 702. 709. I must have had it in there sideways. 719. 721. 735. 741. I can get a little bit larger. But this is my own judging of, I want this hole. This is the speed I want to go at. Okay, so I have to drop down recommended towards set 110 inches per minute. Even if we went to the 1/8 quality or 1/8 thickness of the recommended chart for the, it said 80 inches a minute. Okay, so, and I played up and down with my heights. I kind of tend to run just a little bit less than the 190 because the contact tip sticks out a little bit past your regular contact or your regular tip on the torch. So I think that little air gap kind of it sets you back farther than what in reality is the 190 from your nozzle. But that's yet to be proven. Right here it proves that 190 on the height cuts the best at 25 inches. Alright, and if you look at the rest of my 1/2 inch, of course I've dressed this up on the backside barely, but this is right off the machine, a little tiny bit of grind on the side, but not much at all to dress that up. 3/8. Now this was right off the machine, no dressing at all. And I didn't write down the speed that I actually put this on. I know I was 20 inches a minute or so on that 1/2 inch, and I might have been like 25 or something like that on the 3/8. Now this is a piece of 1/8, and this 1/8 has a little bit of a flare out, which is measured. I was measuring 401 there, and I got like 419 there, 426 there. You know, and also too, this doesn't, I forget where this starts and where it ends, but when you got heat moving this thing around as well, you'll tend to have slightly fatter areas than not. So kind of how you cut, where you set it up to cut, and also how your cut is finishing up in relationship to your main plate. You don't want to start your cut on the main plate and then come back around the real skinny lip near the edge, because you're going to lose control of the whole part itself. If you start a cut and then come and do all the outside first and come back to your joining main plate, you're going to have a truer cut part. Alright, I'm kind of done talking about how I come up with my speed and height and everything else for this project right now, and I'm going to go ahead and start out, and I want to cut my first tail out of this plate. dross on the back side. I'm really looking at how close, how fine those are. Because, I mean, I'm going to have a vertical running through those, and these are going to be horizontal, you know, and the rudder stem's going to come down through there. Alright, we get a flat plate that gets welded to the top and bottom. And then the skin will be drilled out and rosette welded through the outside of the skin. Alright, we're going to let this cool a little bit and then we can play with it by hand.